What's up? I'm Vin, and today I want to go through the AP Calc BC 2012 practice test. So let's get started. And for question 1 here, we have y equals sine of x all raised to the third power. So when we want to take this derivative here, we're just going to use the chain rule. And just be very careful. The power 3 is the outside function. So when we do the chain rule, we have to start with the power 3. And we're going to have 3 times sine squared of x. And the derivative of the base sine x is equal to cosine x. So when we do all this, we use the chain rule. We're going to match this to choice E. Now for the second question here, we're given the position of some particle in the xy plane, and we have equations for the x and y component of the position. And we want to know at which point is the particle at rest. Now the key idea for this is that the particle is at rest when the velocity is equal to 0. So to find the velocity, we have to find the velocity of the x and y component. So if we label this here, the velocity of the x component of the particle, we're going to do the power rule on this equation here, and we're going to get 3t squared minus 6t. And the velocity in the x is equal to 0 when this expression is equal to 0. And if we factor it, we get 3t times t minus 2 is equal to 0. And this gives us 2 times. T equals 0, and we have t is equal to 2. So the next thing we need to find here is the velocity of the y component. Because remember, both components have to be 0 for the particle to be at rest. And if we take the derivative of y of t, we're going to get 12 minus 6 times t. And 12 minus 6t is equal to 0 when t is equal to 2. So this tells us the time where both the x and y component of the velocity is 0 occurs at t equals 2. But what we want to know is not the time. We want to know at which point is the particle at rest. So we need to plug t equals 2 back into the position functions, and we'll have our answer. So we have x of 2 is equal to 2 to the third power minus 3 times 2 squared. And if we work this out, we have 8 minus 3 times 4 is 12, giving us an x component of negative 4. Now this is enough for us to say choice A, but just to be sure we did this right, let's go ahead and plug into the y part. And when we plug 2 into the y position, we're going to get 12 times 2 minus 3 times 2 squared. And for this part, we get 24 minus 12, which is equal to 12. So then it definitely matches here that the point we're interested in is choice A, negative 4, 12. Now for this third question here, we want to evaluate this definite integral going from 0 to 4. And notice we have a piecewise function that has a domain from 0 to 2, and then from x equals 2 to x equals 4. And from 0 to 2, this area formed here is in the shape of a trapezoid. So we just have to find the area of this trapezoid, but be careful. The height of the trapezoid is going horizontal and the bases are going vertical. The way you identify the bases is you look for the sides that are parallel. So we're doing 1/2 the height, and the height is 2 units across. And then we're multiplying this by the sum of the 2 bases. And the first base has a length of 1. And the second base, the longer one, goes from 0 all the way up to y equals 5. So that distance is going to be 5 units. But then we also have to consider the second part of this here, this rectangle going from x equals 2 to x equals 4. And when we find the area here, we just have to identify the dimensions of this. This is going across 2 units, and it's going down 3 units. So while the area of this rectangle is 6 square units, since it's under the x-axis, we have to treat this as a minus 6. And now to simplify everything, we just evaluate. We have half of 2 is equal to 1, and then we get 6 minus 6, which is equal to 0. So this definite integral evaluates to 0, so we're going with choice B. Now for question 4, we want to find the length of this curve, y equals natural log x, from x equals 1 to x equals 2. So for this, you have to know the arc length formula, which is you write your limits. We're going from x equals 1 to x equals 2, and it's the square root of 1 plus the derivative of the function squared dx. So we just have to know the derivative of the original function. So we're taking the derivative of natural log x, which is 1 over x. And then we just plug in here. And if we were to simplify this, this would be 1 plus 1 over x squared, which would match choice A. B is tempting, but there's no square root attached to it. And the other choices are just way too far off. Now for question 5, we want to evaluate f of x at x equals 3, where f of x is the Maclaurin series. So if we evaluate f of 3, the first thing we're going to do is we rewrite this series. We have a summation from n equals 0 to infinity, And instead of negative x over 4, we're going to have negative 3 over 4 because we're evaluating f of x at x equals 3. And this is being raised to the n power. But the key to evaluating this type of series, this geometric series quickly, is you have to just think about if I were to expand this, the first term I would have n to the 0, which gives me 1. But then I would have plus negative 3/4 to the first power, plus negative 3/4 to the second power, and this continues on and on. So the quick way to evaluate a geometric series is that it's equal to 1 over 1 minus the radius of the geometric series, which in this case is negative 3/4. So I'm just doing 1 over 1 minus negative 3/4. And it doesn't matter where the series starts. You just always write the first term first over 1 minus the radius of the geometric series. And when we simplify this, this is going to be 1 over 1 plus 3/4 because the minus minus changes here. And then if I make common denominators here, I have 1 is equal to 4 over 4. So this gives me 1 over 7/4, which simplifies to 4 over 7. So that's going to work out to choice C for this question. Now for this U-substitution here, we have a lot of steps, but they already defined U for us. So the next thing we should find here to transform this integral is du. And du is going to be equal to 2x dx. But notice here, when we start to transform this integral, this piece, x squared minus 3, is equal to u. But we also have to replace x dx. So I would want to come up with an expression for x dx, and I could get that by dividing by 2. And I would have 1/2 du is equal to x dx. So this is going to be one very important piece that we have to use to answer this question. The next thing we have to be able to replace are the limits. Since the integral is going in terms of u, we have to write our limits in terms of u. So we take our old upper limit, x equals 4, and we're plugging x equals 4 into this equation for u. So when we plug in 4, we have 4 squared minus 3, and 16 minus 3 is equal to 13. So that's our new upper limit. Our new lower limit, we plug x equals negative 1 into this equation for u, and we've got negative 1 squared minus 3, and 1 minus 3 is equal to negative 2. So now we just take all this stuff. Our final answer for this question, our new integral, the limits are going from negative 2 to 13. This x dx we're going to replace with 1/2 du, and then x squared minus 3 to the 5th becomes u to the 5th power. So after we replace everything, we just have to match this, and this is going to be choice C. Now for question 7, we're looking at arc sine x is equal to natural log of y, and we want to find dy dx. So we could start by taking the derivative with respect to x of both sides. And the derivative of arc sine x, or sine inverse x, is 1 over square root of 1 minus x squared. And the derivative with respect to x of natural log y is 1 over y dy dx. We're using the chain rule here, or this shows up a lot in implicit differentiation questions. So then all we have to solve for here is dy dx, so we're going to multiply both sides by y. And then the resulting fraction, our final answer, is going to be y over square root of 1 minus x squared. That's dy dx. And we look to the answer choices here, and this is going to match choice A. Now for this next question here, we have a tank that already has 50 liters of oil at t equals 4 hours, and oil is being pumped into the tank at a rate r of t. And we have a table of values with r of t above. And we want to know how much oil is in the tank at the time t equals 15 hours. So the idea behind this question is that there's already 50 liters of oil inside this tank. And we want to know how much more oil accumulates from t equals 4 to t equals 15 hours, and r of t is the rate that oil is being pumped into this tank. Now, if this concept doesn't make a ton of sense, just know r of t is in liters per hour, and dt, the change in time, is in hours. So when you multiply liters per hour by hours, that's giving you just liters, which does answer the question of how much oil is in the tank. So that's why we integrate. Now, the other idea is we have to do a Riemann sum, where you're doing a right Riemann sum, and we're going from t equals 4 to t equals 15. So if you could do this with just the table of values, then awesome. But if you have trouble seeing like how this works, at t equals 4, we're at 6.5, so we're starting up here. But then at t equals 7, we're not going to draw this to scale. We're going from 6.5 down to 6.2, and I'll write that right above this point. And then at 12, we're going down to 5.9. and at t equals 15, we're going down to 5.6. So then the concept is that we want to find the area under this curve from t equals 4 to t equals 15, but using the right Riemann sum, from 4 to 7 is a distance of 3, and we're going with the value on the right, so this is going to be a height of 6.2. Then from 7 to 12 is a distance of 5, and we're going with the value on the right, which is 5.9. And then from 12 to 15, that distance is 3 units across, and we're going with this value on the right. We're going with 5.6. So all we have to do to answer this question here is we're going to do 50 plus the area of these 3 rectangles. The other way of doing this with just the table is to say from 4 to 7 is a change of 3, and I go with the value on the right, which is 6.2, which you could see right away is the area of this first rectangle. And then from 7 to 12 is a distance of 5. The value on the right is 5.9, and 5 times 5.9 gives us the area of the second rectangle. And now we've got plus 3 times, because that's the distance from 12 to 15, the value on the right is 5.6. So then the rest here is just arithmetic. We have to just be able to add all this stuff up. So we have 50 plus, and if I do 3 times 6.2, I do 3 times 6 is 18, and 0.2 times 3 is 0.6. So I get this here. This one's a little bit more annoying to do in your head. I would think of this as like 6 minus 0.1. And then if I do 5 times 6, I get 30. 5 times 0.1 is 0.5, and 30 minus 0.5 is 29.5. And then I've got plus 3 times 5 is 15. 3 times 0.6 is 1.8, and 15 plus 1.8 is 16.8. So I just have to write all this stuff out, and then the rest is just doing the addition. It's kind of annoying that they put this question in the no calculator section. I think this, just because of this addition alone, this should probably be in the calculator section, but you know what, sometimes you have to do a little bit of adding, and it's not such a big deal. So here I got 6 plus 5 is 11, plus 8 is 19. Carry the 1, bring the decimal down. 1 plus 8 is 9, plus another 9 is 18, plus 6 is 24. Carry the 2. We got 7, 8, 10, 11. So 114.9. This is going to be choice C. So for this third question here, we want to know which of these series converge. And my first idea is that factorials increase at a faster rate than exponentials and power functions. So in this case here, since the factorial term is in the denominator, this series is going to converge. Just by looking at it, I could tell by the idea that factorials increase faster than exponentials. And factorials increase faster than power functions. So just looking at this, if the term that increases faster is in the numerator, then I know that this second series is going to diverge by the nth term test. And then this last one here, what am I thinking about that tells me that this thing converges just by glancing at it? Is that I think about this, it reminds me of n over n times n times n, which is n to the third power. Because with series, the leading terms are the ones that matter the most. And this is going to work out to 1 over n squared, which is a convergent p-series. So just by looking at this, without doing too much heavy lifting, I want to say that this is choice D. Now, if I have plenty of time on the test here, I'm going to use the ratio test for 1 and 2. If I really have the time and I want to be 100% sure here that this is definitely it. So if I do the limit as n goes to infinity of the n plus 1 term, which is 8 to the n plus 1 over n plus 1 factorial, and then I divide by the original term here, 8 to the n over n factorial. When I divide, it's just going to flip this to n factorial over 8 to the n power. And then when I work this out, I'm going to have the limit as n goes to infinity of 8 to the n plus 1 over 8 to the n works out to just 8. And then n factorial over n plus 1 factorial works out to just n plus 1. Because remember, n plus 1 factorial is the same thing as n plus 1 times n factorial. So the n factorials would cancel, leaving us with just this. And this limit goes to 0. So by the ratio test, I could say that this series converges. And if I run this through the ratio test too, I'm going to get something infinite, which is going to tell me that number 2 diverges. And for the last one, if I want to show a lot of work, I would do a limit comparison to 1 over n squared. And if you take the limit as n goes to infinity of n plus 1 over n times n plus 2, n plus 3 over 1 over n squared, you could work this out here And this is going to work out to something positive and finite, which by the limit comparison test tells us the original series is going to converge. So this here, what I could do is see that the only terms that really matter are the leading terms. So I could say this is equal to the limit of n over n to the third over 1 over n squared, and this limit is equal to 1 because I have 1 over n squared over 1 over n squared, and because this is positive and finite, so this is positive and finite, by the limit comparison test, I could say that this third series converges as well. So moving on to question 10 here, we're just going to use the fundamental theorem of calculus part 1. I'm going to do the antiderivative, so negative 3 over 2 plus 1 is going to give me negative 1/2. And when I divide by negative half, that's going to put a coefficient of negative 2 in front. And I'm evaluating this from t equals 1 to t equals 4. So the negative 2 I'll just leave outside because it's a constant. And I'm going to have 4 to the negative 1/2 minus 1 to the negative 1/2, which is going to give me negative 2. And this is going to be 1 over the square root of 4 just minus 1. So I get negative 2 times 1/2 minus 1. And I get negative 2 times negative 1/2, which is equal to positive 1, giving me choice E for question 10. So for question 11 here, we're analyzing f of x, which is the square root of absolute value x minus 2. And we want to know which of these statements is true. And for choice A, we have f is continuous but not differentiable at x equals 2. And my first glance at this tells me I have absolute value of x minus 2. And if we think about what this graph looks like, it's in the shape of a V. But one thing that we do know is that it's always positive or 0 at x equals 2. So when I take the square root of something that's always positive or 0, there are no restrictions on my domain. So my domain is all real numbers. And that's telling me at first glance that this function is continuous everywhere. So when we have f is not continuous at x equals 2, I could get rid of this choice here because I know at x equals 2 I could plug in and the y value is 0, but I could also plug in values after 2 and before 2 and have no restrictions. So for choice D, if I look at this and say, well, what is the limit as x approaches 2 of our function f of x? And this, because it's continuous everywhere, I could evaluate by direct substitution, and that's just going to give me the square root of absolute value of 0, which is just going to give us 0. So this, in fact, is a false statement because the limit is equal to 0. Now, x equals 2 is a vertical asymptote of the graph. Remember, the domain is all real numbers, so we don't have any asymptotes. The only time you are going to have an asymptote, let's say g of x, would be if I had something in the shape of this. If I had even something like x over x squared minus 2x, which would give me x over x times x minus 2. And when I factor and cancel everything and I have leftover factors in the denominator, whatever the roots of those leftover factors are in the denominator are, tell me where my vertical asymptotes are. So in a situation like this, I would have a vertical asymptote, but that's not what's going on here. So now it's between A and B. And how I know that it's going to be A and not B is I take the derivative of this, but we don't have to take the derivative the whole way. I know that the derivative of square root x is 1 over 2 square root x. So I start this by writing 1 over 2 square root, and I have absolute value of x minus 2. But I also have to do the derivative of the inside. But as it turns out, this is multiple choice. We don't care what the entire derivative is. We just have to think about what happens if I were to plug in 2. And if I were to plug in 2, f prime of 2 is undefined because I would have 1 over 2 times the square root of 0. And division by 0 is no good. So this is undefined, f prime of 2. And since f prime of 2 is undefined, that tells us that our function is not differentiable at x equals 2. Now for question 12 here, we have these 2 points, -1, -1, and 1, -5, on the graph of the function y equals f of x. And they satisfy this differential equation. We have x squared plus y. And we want to know which of the following must be true. So if we run -1, -1 through this, then y prime I'm going to write just to save time and space at -1, -1, if I plug in is -1 squared plus -1, which gives me 1 minus 1, which is equal to 0. So I have to be on the lookout for this point now. This is a significant point because anytime your derivative is equal to 0, that means we have a critical point here. So we just have to investigate this a little bit more. And what we're going to do is we're also going to look at the second derivative. when they're using language like points of inflection, local minimum, local maximum, we're going to want to use the second derivative test on -1, -1. So if we take the second derivative, d squared y over dx squared, the derivative of x squared is just 2x, plus the derivative of y is dy dx. So if I plug in -1, -1 to this function into the second derivative, what I'm going to have is 2 times x is -1 gives me -2, plus, and remember, we just found what is the derivative at -1, -1, it's equal to 0. So this tells me that my second derivative is negative at -1, -1. But now you have to think about this. The slope at -1, -1, we're told is equal to 0, and the second derivative coming out negative tells us this function is concave down in this neighborhood, which means it's in the shape of an upside down U. It's frowning at us. Concave down is in this shape here, which means that by the second derivative test, if your first derivative works out to 0 and the second derivative comes out negative, that means you have a local maximum, because you see it makes a hill at this point. So -1, -1 is a local maximum of f. Now, just to be sure, because this test is high stakes, how do you know there's nothing special going on with the second point? And if you were to plug in the second point, 1, -5, into the derivative, you're going to get 1 minus 5 is -4, which just tells you that the slope is negative at this place. And do we have anything special going on with the point of inflection? Well, when we look at the second derivative at this point, if you want to investigate a little bit more, then what we could do is we plug in, we have 2 times 1, because we have 2 times x, plus the first derivative at the point 1, 5, I'm sorry, at the point 1, -5, which we just found to be equal to -4. And when we do 2 minus 4, that's going to give us -2. So this just tells us that our curve is decreasing and concave down here, which is nothing special in terms of what's available in the answer choices. So we're going to go with choice C. Now this third question here is a really fun question. So the key here is to rewrite this in a different form. That x minus 4 to the 2n, you could write as x minus 4 squared then to the n power. So I could write this whole thing as x minus 4 squared to the n power, but notice 3 is also being raised to the n power. So in the bigger parentheses, I have x minus 4 squared over 3. And this is resembling a geometric series. And remember, a geometric series only converges when you have some term in here that's between -1 and 1. And the only way that this term is going to be between -1 and 1 is when the term x minus 4 squared is some number between -3 and 3. Or I could say when the absolute value of x minus 4 squared is less than 3. Okay, so this is the idea, that whatever x minus 4 squared is, the absolute value of this thing has to be less than 3, because then I'll have a fraction that's between -1 and 1, and then it will converge because it's a geometric series. But the idea behind this, x minus 4 squared is always positive or 0 when x is equal to 4. So I could just get rid of the absolute value here and write x minus 4 squared is less than 3. But then from this step, this is not in a proper form for us to be able to identify our answer, so I'm going to take the square root of both sides. And what I have is the square root of x minus 4 squared. Be careful. Don't say x minus 4. It's absolute value x minus 4. And this is going to be less than square root of 3. And when it's in this form here, we know that our center of this series is going to be at x equals 4, and our radius of convergence is going to be square root 3. So once it's in this form here, x minus the center less than some number, that number is your radius of convergence. And that tells us here that our answer is choice C. All right, question 14 is so easy that it's difficult. Which of the following is a logistic differential equation? Just know your definitions and your formulas, because for a question like this, if you didn't memorize, then you just miss. But if you know your formulas, this is the one form of a logistic differential equation, choice E. Now for question 15, we have this function h of x, which represents the area under f. And we want to talk about h, h prime, and h double prime. So the first one, h of 6, if we think about it very carefully, this is the integral from 0 to 6 of f of t dt. And when we think about the area from 0 to 6, this curve is entirely under the x-axis from 0 to 6. So whatever this is equal to, the value doesn't matter, but all that does matter is that this is going to come out negative. And now when we want to start talking about h prime of x, h prime of x, if we take the derivative of both sides, is equal to f of x. And this is true. We don't have to say why, considering it's multiple choice, but this is the fundamental theorem of calculus part 2. That when you take the derivative of an area function, the integral cancels out, giving you just f of x, because it's going from a constant up to x. So using this idea then, we could say that h prime of 6 is just equal to the function value at 6. And if you notice, the function value at 6 is right on the axis, so it's going to be equal to 0. And then the next function we have to talk about is h double prime of x, which is equal to f prime of x. And think of this as the slope. So this is the slope of f of x. So when we want to talk about what is h double prime of 6, this is equal to the slope of f at x equals 6. And the slope here, it doesn't matter what the value is, but I think it's clearly obvious here. If you look carefully, this function is increasing. So the slope there is positive. Now, these are being ordered from least to greatest. So this tells us since h is negative, h of 6 is the smallest. And then the next one is going to be h prime of 6 because that's equal to 0. And then whatever the positive value is going to be bigger than 0. So that means h double prime of 6 is the biggest one here. So if we look through the answer key, that's going to match up with choice A. So for question 16, we're going to use Euler's method, and we have two steps of equal length, and we want to approximate f of 2, and we're starting with f of 1 equals 3. So I highly recommend for these questions to make a little table, and we have x, we have dy dx, and then we have the y value here. And what we could do is we have x is equal to 1, y is equal to 3. We're just translating f of 1 equals 3 into the point form xy. And when we plug this into our derivative, 1 minus 3 is going to give us a slope or a derivative of negative 2. And then what we do here is we write this equation of a line. We would have y minus 3 equals negative 2 times x minus 1. And if I solve this, I'm going to get negative 2 x minus 1 plus 3. But we're doing two steps of equal length. So if we're taking two steps of equal length to get to x equals 2, that means we're going to count by 1/2. So if I do 1 plus a half, that gets me here, and 1 1/2 plus a half gets me here. But we use this tangent line from this row to approximate the next one. So we go ahead and do that here. We're going to plug in x equals 1.5. And when we plug in x equals 1.5, we're going to get y equals negative 2. And 1 1/2 minus 1 is just equal to a half. And now we've got plus 3. And if we solve this out, we're going to get negative 1 plus 3 is equal to positive 2. So that's what's going here. And now we find the derivative using these 2 points next. And if we plug these 2 points in, we're doing 1 1/2 is x minus y is equal to 2, which gives you negative 1/2 or negative 0.5. And now we go through this process all over again. We're going to make a new equation of a line, except this time it's going to be y minus 2 equals the slope, negative 1/2, times x minus 1.5. And now we just solve this out. We have negative 1/2 x minus 1.5 plus 2. And what we're going to do is we plug in x equals 2, and we'll get our approximation for the function at x equals 2. So we're going to have y equals negative 1/2. When we plug in x equals 2, we're going to have 2 minus 1 1/2 is 1/2, and then we get plus 2. So now we've got y equals negative 1/4 plus 2, but 2 is equal to 8 over 4. So this is just going to be equal to 7/4. And y equals 7/4 is our approximation for f of 2. So we're going to go with choice C here. So for this question here, we're dealing with this power series, and we want to know which of the following does it converge to. And for this, the trick is that you have to try to match it up with something that you do recognize. So right away looking at this, if f of x is equal to, we have 1 minus x squared over 3 factorial plus x to the 4th over 5 factorial, and so on. This goes all the way down the line to negative 1 to the n, x to the 2n over 2n plus 1 factorial. What jumped out at me right away is that it would be so much nicer if this was x to the third over 3 factorial, x to the fifth over 5 factorial, because then it would match up with the power series for sine of x. So what I would do here is multiply everything by x. So we would have x times f of x, and if I multiply everything by x, now I get x instead of 1, and if I multiply x squared by x, I get x to the third. The 3 factorial, the bottom is not changing here. We're just multiplying everything across the top by x. And then next I would have x to the fifth over 5 factorial, and this goes on and on, minus all the way down, and I'd have negative 1 to the n. X to the 2n times x to the first becomes x to the 2n plus 1, and this is over 2n plus 1 factorial. And keep in mind, yeah, these are infinite series. They're just going to go on and on like this. But now what I have is that this is x f of x equals, and this odd power series, these are all odd degrees of x, is the power series expansion for sine of x. So then here, to solve for f of x, what is the original function? I just divide both sides by x. And that tells me that f of x is equal to sine x over x. So we're going with choice C. Okay, for this question here, we have a graph of the derivative f prime, and we want to talk about what is f of negative 5 if we know that f of 2 is equal to 1. So for questions like this, the idea behind it is that the antiderivative of f prime gives you f of x. But the strategy here is like, how do you pick the limits correctly? So what I would do here is the smaller number is negative 5, and the bigger number is positive 2. And when you think about what does this mean in terms of the fundamental theorem of calculus part 1, I would do the antiderivative of f prime of x, which is f of x, and then I would plug in the upper limit 2, the lower limit negative 5, and I would subtract them. So if I want to know what is f of negative 5, then all I have to do here is find the value here and subtract f of 2. So we just go through the process now and see what is the area under the curve from negative 5 to 2. And what we have here, from negative 5, this is x equals negative 5, up until negative 2, this part is just a triangle, and it goes up 2 units, and it goes across 1, 2, 3 units. So I would do 3 times 2 is 6, and I cut that in half, and that's equal to 3. So that's the area of this piece. But then I'm going all the way to positive 2. And for this next portion here, the area of this component, it's a semicircle with radius 2. So for this part, this is pi times the radius squared divided by 2, which is equal to 2 pi. But be mindful, this area 2 pi is under the x-axis, so we have to treat it as negative. So this starts off as 3, because we have this triangle with positive area above, minus 2 pi, we have signed area underneath, and this is equal to f of 2, which is 1, minus f of negative 5. And then here we just have to do the algebra, subtract 1 on both sides, and we're going to have 2 minus 2 pi is equal to minus f of negative 5. So just multiply everything by negative 1, and f of negative 5 is equal to positive 2 pi minus 2, which corresponds to choice A. So for this next question here, we have a function f of x, and we want to know which points on the graph of f have the property that the line tangent to f of x at those points have a slope of 1/2. So the moment you hear when is the slope equal to 1/2, you're going to take the derivative, and you're going to set the derivative equal to 1/2. So we're just going to do the quotient rule here. We're going to have x plus 2 times the derivative of the numerator, which is 1, minus x times the derivative of the denominator is 1, and we're dividing by x plus 2 squared. So this is going to work out to x plus 2 minus x over x plus 2 squared, and the x minus x is going to cancel, giving you f prime of x is equal to 2 over x plus 2 squared. But now what we have here is we want to know when is this derivative, when is 2 over x plus 2 squared equal to 1/2. And the rest is just all algebra. We could cross multiply here, and we'll have x plus 2 squared times 1 is x plus 2 squared, and this is equal to 2 times 2, which is 4. Now you could expand this and do all that, but honestly the easier way to do this is just to use the square root property. And the square root of x plus 2 squared is going to give us x plus 2 equals plus or minus positive 2 here. So if we solve out both of those equations, we have x plus 2 equals positive 2, which gives us x equals 0, and we also have x plus 2 equals negative 2, and when we subtract 2 here, we get x equals negative 4. Now right away, I see an answer where we have a 0 and a negative 4 in the x spot, but just to be 100% sure, what I would do is say, what's the y value when I plug in x equals 0 to my original function? And I'd have 0 divided by 2, which is equal to 0. And then I also have, for this one here, what is my y value? I would have x equals negative 4 up top, and I would have negative 4 plus 2, which is negative 2 on bottom, and this works out to positive 2. So notice I have 0, 0, and I also have negative 4, 2, which corresponds to choice C. So for question 20, we're starting off with this definite integral here, and to evaluate this, we're going to use integration by partial fractions. Now to start, we're going to write out the numerator, and you want to factor the bottom as x plus 2 times x plus 1. So this is ultimately what we want to find, but once again, I'm going to do all the algebra on the side. I'm not going to keep writing this integral notation. So what I would have is a over x plus 2 plus b over x plus 1. So I want to be able to break this up into two separate fractions because these are much easier to do the antiderivative of. They're just going to be basic natural log antiderivatives. But this is going to be equal to 5x plus 8 over, and we have x plus 2 times x plus 1. Now, what we would do here to get these to have common denominators, I would multiply a times x plus 1, and I would multiply the bottom by x plus 1. But that would give me a times x plus 1 plus, and this second fraction we would multiply by x plus 2 over x plus 2, which would give me b times x plus 2. And then the only way the sum of these two numerators would be equal to this would be if a times x plus 1 plus b times x plus 2 was equal to 5x plus 8. So we're just assuming here that after we do this split that we want to put everything back together, then these two sums here would have to equal 5x plus 8. So now here, the fastest way to go through this is to just plug in test values. I would plug in x equals negative 1 because that would make this first term just cancel out completely. I would get a times 0 just wiping out. And then I would get b times negative 1 plus 2 just gives me a 1. And then here I would have 5 times negative 1, which is negative 5, plus 8 is equal to 3, giving me the value that b is equal to 3. So we solved for one of the coefficients here that we need. Now the next thing I would plug in is going to be x equals negative 2 because that would completely wipe this out. And if I plug in x equals negative 2, I'm going to get negative 2 plus 1 is negative 1. So I'll have negative 1 times a plus 0, because remember, negative 2 is going to cancel this out. And that's going to equal, if I plug in negative 2, I've got negative 10, doing 5 times negative 2, plus 8 is negative 2, and I divide everything by negative 1, and I get a equals positive 2. So what this tells me then is that this integral can be broken up into two separate integrals. This is going to be equal to the integral from 0 to 1 of a over x plus 2. Remember, a we just found is equal to 2. So I get this integral plus b was equal to 3, and b is attached to the x plus 1. So this is 3 over x plus 1 dx. And now you just do the antiderivatives. Oh, and this is going from 0 to 1. We can't forget the limits. And now we've got 2 natural log absolute value x plus 2 plus 3 natural log absolute value x plus 1 here like this. And this is going from, once again, it's going from 0 to 1. So to work this out here, all we have to do from this step is just plug in the limits and subtract. So we're going to have 2 natural log, and the absolute value could go away for this part because absolute value of, let's just fix that. 1 plus 2 gives us 3. The absolute value of 3 is just 3. Plus 3 times, and then we'd have natural log 1 plus 1 is 2. And now we have minus, and we're plugging in 0. So we have 2 natural log 0 plus 2 is 2. So I have 2 natural log 2. And then for this part, I have 3 natural log of 0 plus 1 is 1. And natural log of 1 is 0. So I get one thing to cancel out here. And then to close this out, what do we have? We have 2 natural log 3. But now I have 3 natural log 2 minus 2 natural log 2s, which is just a natural log 2. But if you look at the answer key, nothing there matches what we have, but we can make it match. I could send this 2 back in as an exponent, and that would give me natural log of 3 to the second power, which is 9, plus natural log of 2, and this is equal to natural log of 9 times 2, which is natural log of 18. So this is going to work out to choice C. So for question 21, we want to know y equals 5 is a horizontal asymptote to the graph of which function. So the idea behind this is that this is only going to be true if the limit as x approaches plus or minus infinity of one of these functions, f of x, is equal to 5. So when I just look at all of these, you just have to be able to do limits at infinity kind of quickly in your head. And you can see here that this limit as x goes to plus minus infinity is just going to go to 0. So this is not going to be it, because the denominator is going to outpace the numerator. The numerator just bounces from 1 to -1, but x is just going to become very large. The limit as x goes to plus or minus infinity, well, as x goes to positive infinity, 5 times infinity heads towards infinity. And as we go to negative infinity, just think of what this looks like. You can see this thing is going down to negative infinity. So we don't have an asymptote for a linear function. Now for the next one here, y equals 1 over x minus 5. All we have here is the limit as x goes to plus or minus infinity is going to 0. So this one is out. And then we're going through this one here. The limit as x goes to plus or minus infinity. I just look at the leading terms here, and I have 5x over negative x. So when I think about this, because in the multiple choice, the notation doesn't matter, this is heading towards -5. So I know if the answer was y equals -5, then we would be in business, but that's not the case. So then finally we get to the last one here, and when you think about the leading terms in this case, I have a 20x squared. That's the highest power of x on top, and I have the highest power of x on bottom is a 4x squared. And when you take the limit at infinity, this is heading to 5, and that matches what we need. So this one is going to be choice E. So for question 22 here, we're told that this power series converges at x equals 5. So the first thing I would do here, before we look for which of the following must be true, is I would plug in x equals 5 to this power series. And if we do that, we're going to have 5 minus 3 is 2, and this is going to be raised to the n power. And we're told that this power series definitely converges when x is equal to 5. And what that tells us, when we look at this very carefully, 2 to the n gets to be way out of control as n goes to infinity. This just takes off. So if we just focus on a sub n, this tells us a few things about a sub n. That the limit as n goes to infinity of a sub n has to be equal to 0. And also, this means that the sequence of terms for just a sub n has to be decreasing. So this sequence is decreasing. And when you look at this language together, this is shouting out the conditions for the alternating series test. So the strategy here that we want to use is to try to use the alternating series test. So this is what we want to use, and I'm just going to abbreviate that here. So which of these values of x are going to turn this into a situation where we have an alternating series where a sub n is the term outside of the -1 to the n. So the goal is we want to create a series that's in the form of -1 to the n times a sub n, because if we have an alternating series and the limit as n goes to infinity of the general term goes to 0 and this part a sub n is decreasing, then by the alternating series test this converges. So we just have to strategically look at this. How do we make x minus 3 equal -1? And if you think about it very carefully, that's going to tell us that we have to go with an x value of 2. Because when we plug in 2 here, at x equals 2, this is going to give us the series a sub n, and we would have 2 minus 3 to the n power, which is going to give us the series a sub n times -1 to the n here. So we're going with choice D for question 22. Question 23 is another one of those questions that you could answer very, very quickly if you know what they're looking for. So they have P of t is the size of a population at any time t. And we want to know which of the following differential equations describes linear growth in the size of the population. So if we're dealing with linear growth in the size of the population, think about it very carefully. Linear growth has a constant rate of change. You think about any line that you could draw, and if you're drawing a line, the slope doesn't change. the slope is constant. So you're looking for a slope or a derivative that is constant and doesn't change at all. And the only one here that's constant is choice A, a slope of 200. And this is just a constant 200. Notice for this choice, it's dependent upon the variable t. This one is also dependent upon the variable t. And then the last two choices are dependent upon the population at any given time. So for question 24, we want to find out which of the following functions could be f of x. And this is an integration by parts question. And notice here, f of x, if we were to run this through integration by parts, this would represent our u term, and sine of x dx would represent our dv term. So we would have u is equal to f of x. We would have dv is equal to sine x dx. So if we were to take du here, this would be f prime of x dx, and then v, the antiderivative here, would be, we would have negative cosine x. So if we run it through the formula, notice we have u times v, and that's giving us, when we take this antiderivative, we have negative f of x cosine x, but then we have minus v times du, which is going to give us negative cosine x times f prime of x dx, and the minus minus changes this to a plus. And we have the integral of cosine x f prime of x dx. So once again, we're just using the general formula for integration by parts here, that it's equal to u times v minus the integral of v du. And when we run the formula through for the question they gave us, now we just have to look for the missing piece. And notice negative f of x cosine x matches everything we have here, but the part that we have to most look out for, we have a cosine x dx, but this is the part that jumps out. 4x to the third is going to match up with f prime of x. So if we have f prime of x is equal to 4x to the third, then we just have to say what could be the function f of x. Well, if we do the antiderivative of this quickly, this is x to the fourth plus any constant they could come up with. But notice the only one that remotely resembles this is choice E of just x to the fourth power. So that's going to be our answer choice for 24. So for question 25 here, we just have to go through the process of evaluating an improper integral. So 1 to infinity, this integral from 1 to infinity, we're going to write as the integral from 1 to b, and we're taking the limit as b goes to infinity. And we have xe to the negative x squared. And what I want to do here is do most of the work. Oh yeah, let's not forget this dx. But I want to do most of the work on the side, and we're going to do a U-substitution where u is equal to negative x squared. So then du is equal to negative 2x dx. And if I want to solve for x dx, I'm going to move the negative 2 over, and it gives me negative 1/2 du is equal to x dx. So now I could rewrite this integral, and I'm just going to do the general antiderivative, and then I'll plug it in later. But the general antiderivative here is going to give me, well, x dx is negative 1/2 du, and then instead of e to the negative x squared, I'm going to have e to the u power. So this is going to work out to negative 1/2 e to the u plus a constant, and then I have negative 1/2 e to the negative x squared plus c. But remember, when I use this for the antiderivative, I don't need the plus c. That's only for indefinite integrals. So now here we plug this in, and we'll keep this all separate. This is the limit as b goes to infinity of, and now we take our antiderivative. It was negative 1/2 e to the negative x squared, and we're evaluating this from x equals 1 up to x equals b. So then we just make our substitution here, and then we could do the limit in the one of the last steps here. But we're going to have negative 1/2, and we have e to the negative b squared minus e to the negative, and we have a 1 squared here. So when we go through with this part here, now we have the limit as b goes to infinity, and we've got negative 1/2 times, this is 1 over e to the b squared, and then this is going to give me e to the negative 1. When I have negative 1 and then raised to the second without parentheses, that's going to be e to the negative 1, so I have minus 1 over e. And now from here, I just have to think, what happens as b goes to infinity? Well, then I have 1 over e to the infinity squared, which is going to shrink to 0. So I have a negative 1/2, and I've got 0 minus 1 over e. And when I distribute the negative 1/2, Distributing to 0 does nothing. It's just going to be 0. But negative 1/2 times negative 1 over e is going to be a positive 1 over 2e. And if I look in the answer key, this matches choice B. So for this question here, we want to find the slope of the line tangent to the polar curve, r equals 1 plus 2 cosine theta, at theta equals 0. So the idea you need for this question is that the slope, dy dx, is equal to dy d theta divided by dx d theta. In a sense, like if you do keep, change, flip, the d thetas cancel out and bring you right back to this. But then the next thing that you do need to know is that x is equal to r cosine theta and y is equal to r sine theta. So what I could do is just make a substitution. X equals, and r is 1 plus 2 sine theta, and I'm doing r times cosine theta, so there's going to be an extra cosine theta out here. Now there is a formula for this, but I always forget it, so I always wind up re-deriving it on the spot. So just make sure like you don't have to spend all that time memorizing formulas for the AP test. It takes a little of the pressure off knowing you could just figure them out on the spot. So now I have r times sine theta, and that's going to give me 1 plus 2 sine theta, and I have an extra sine theta out here. This one I would actually take the time to distribute. If I do sine theta times 1, that's sine theta, and then plus 2, and I have sine theta times sine theta is sine squared theta. So then what I want to do in the next part here is take the derivative here. I have dx d theta for this part, and now I'm going to use the product rule. The derivative of 1 plus 2 sine theta is just 2 cosine theta, and it's going to be just 2 cosine theta times cosine theta. And now I have plus, and I've got 1 plus 2 sine theta, and the derivative of cosine theta is negative sine theta. So that's dx d theta. Now for this part, dy d theta, this one's a little bit easier, but the derivative of sine is just cosine. And now I've got plus, and I got to do the chain rule here. I'm going to use the power rule first. I'm doing 2 times 2 is 4. So I got 4 sine theta, and then the derivative of the base is cosine theta. So for the next step here, dy dx is equal to, we have cosine theta plus 4 sine theta cosine theta, and this is all being divided by this messy derivative here. This would give me 2 cosine squared theta, and then I'd have plus 1 plus 2 sine theta times negative sine theta. But they're going to give us a nice value to plug in. We want to know what is the derivative at theta equals 0. So when we plug in 0, cosine of 0 is 1. So I'm going to have 1 plus, and 4 times sine of 0 is 0. So this whole piece just cancels out, and it gives me a 0. Over, and now I have 2 times cosine of 0 squared. And cosine of 0, once again, is 1. So I'd have 2 times 1 times 1 is 2. And now this looks like a nightmare to evaluate, but it's all being multiplied by negative sine of 0, which is 0. So this entire piece is just going to cancel out. So this whole thing is going to work out to 1/2. So 26 is choice B. So for question 27, we want to know for what values of P will both of these series converge. And for this first series here, this is a P series. And this will only converge when the exponent 2 times P is greater than 1. And this is going to be true when P is greater than 1 over 2. We just solved this by dividing by 2. And the second series is a geometric series. And if we think about it carefully, a geometric series converges when the r value is between -1 and 1. But our r value here is P over 2. So we need P over 2 to be some value between -1 and 1 in order for this second series to converge. And when we multiply everything by 2 all the way across, we're going to have an interval for our P value here. But remember, for both series to converge, both of these inequalities have to be true. P has to be greater than 1/2, and it has to be between -2 and 2. And the only way to make them both simultaneously true is if we set 1/2 to be the smallest value, because P has to be bigger than 1/2, but P cannot go past +2. So P has to be between 1/2 and +2, and this is going to match choice C. Now for this last question here, the first thing you should try when you're evaluating limits is just plugging in. But notice when you try to plug this in here, that when you plug in x equals 1, you're getting the integral from 1 to 1 of g of t dt, and this is equal to 0. And if you plug in 1 on bottom, you're going to get g of 1 minus 6. G of 1 is equal to 6, and this is going to give you 6 minus 6, which is also 0. So plugging in gives you something indeterminate, which means you cannot evaluate the limit when it's in this form. So what we need to do here, because it's a 0 over 0 indeterminate form, is we're going to use L'Hopital's rule. And this is going to be equal to the limit as x approaches 1. And the derivative of the numerator, we're using FTC part 2. The derivative of the integral from 1 to x of g of t dt is just g of x. And on bottom, the derivative of g of x minus 6 is g prime of x. So now when we plug in, we're going to get g of 1 over g prime of 1. And when we simplify this here, g of 1 is equal to 6. They gave this to us. And g prime of 1 is equal to 3. And when we do 6 divided by 3, that's just going to equal 2. So the last question is choice D. Okay, well, this is going to conclude this video on the AP Calc BC practice test. If you found this video to be helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, leave the topics you want me to cover in the comments section below. And thanks for watching.